problem, we're given the initial rates listed in the following table that were determined for this reaction. Nitrogen oxide plus chlorine gives this compound here. So we're given 3 experiments with different concentrations of NO and Cl2 and the rates for those 3 experiments. And we're asked to answer these 3 questions here. What is the rate law? So to do this problem, you want to find 2 experiments where one of the concentrations is constant. Okay, so experiments 1 and 2, the chlorine concentration doesn't change, and the other reactant, NO, changes. And in this case, it changes by 2 times. It doubles, right? So in experiment 2, the concentration is 0.26. That's exactly double of 0.13. So we can take the rates now and analyze those 2 rates by taking the ratios. So we want to take experiment 2 and divide it by experiment 1. Okay, so that's 4.0 times 10 to the minus 2 divided by 1.0 times 10 to the minus 2. And this is a typical textbook problem where it comes out exactly to 4. Okay. Now, what does that tell us? What is the order of this reaction? Well, think about if we have a concentration that doubles and the order is 0, the rate goes up by 1 times. If we double the concentration and the order is 1, 2 to the first power is 2, the rate goes up by 2 times. If we double the concentration of a reactant and the order is 2, 2 squared is 4. It goes up by 4 times. And that's what we observe here. So we can therefore say that the order is 2. Okay, we're looking at the exponent here. Now don't get lost about which chemical we're talking about. We're talking about the one that changes, so that's for the NO. Okay, so the NO order is 2. And we do that same process for the other reactant. So here we see that there's a change, right? But again, focus on what stays the same. So experiments 1 and 3, the NO concentration is exactly the same. And so we're going to be looking at experiments 1 and 3. The concentration doubles, 0.1 to 0.2 is a doubling. Goes up by 2 times, so we want to compare experiment 3 and experiment 1. Okay? So we want to take the ratio of those rates. So experiment 1 over experiment 3 is 1.0 times 10 to the minus 2 divided by 5.0 times 10 to the minus 3. And that's equal to 2. Okay? Again, that's how fast the rate changes. So we want to look over here, and we can see that if the rate doubles, the order is 1 here. Okay? So the Cl2 order is 1. In general, you have 3 possibilities. If there's an exact doubling of the concentrations, the rate will stay the same, it'll double, or it'll quadruple. Okay? So we figured out what the orders are, and we can now write the rate law for this reaction. Rate is equal to some rate constant times the concentration of NO, second power, times chlorine to the first power, or just not being shown there. Okay? Now to work on part B here, we're asked to find what is K. Basically, we just solve for K here. All right, and we pick any experiment. I like to pick the top row here just to avoid getting lost in the data. And we just plug in these values and find out what the rate constant is. So it's 1.0 times 10 to the minus 2 molarity per second divided by the NO concentration, 0.13 molarity. That's going to be squared. and the chlorine concentration is 0.20 molarity. Okay, so plug that in your calculator, and you should find the value of 3.0. And the units are kind of strange. There's a per second, so that's where that comes from. And down in the denominator, we have molarity squared times molarity, which is molarity cubed. And one of the molarities cancels that out, so it's molarity to the -2. All right, let's go ahead and think about this third question here. What is the rate when NO is 0.12 molar and chlorine is 0.12 molar? Well, basically, we're going to use this rate equation here that we figured out, and we're going to use this rate constant, and we're going to plug it in, and we're going to use values of 0.12 for each of the concentrations. So the reaction rate is going to be the rate constant, which we decided was 3.0 with these strange units, times NO squared times chlorine concentration, just to the first power. And what we get for this is 5.2 times 10 to the -3rd molarity per second. Okay. When you're doing this on your calculator, remember that 0.12 squared is 0.12 times 0.12. Don't multiply by 2. Some students make that simple mistake. Thanks for watching.